Good evening, everyone. My name is Brendan McCann, and I'm from Systems Biology Ireland. And the title is There's a Time and a Place. I have a chilling Halloween thought for you tonight. Cancer. 1 in 3 people in this room will get cancer. If it's not the person to your left or the person to your right, then it could be you. In cancer, the normal mechanisms and messages that control our cells go crazy. They turn against us. And this happens because the normal mechanisms go malfunction. Cells are very active with lots of messages being sent all the time, and these messages determine what the cells do. You can think of messages in the cell like messages in a factory. An order comes into a sales operator who passes the message to a production manager, who passes the message to the factory workers, who then go and make stuff. In the cell, instead of person to person, these messages are passed through molecules called proteins, and these messages determine what the cells do. And this is important. In cancer, messages telling the cells to grow and multiply get turned on, and those saying stop get switched off. Now, when this happens, we can target the proteins involved with drugs, but these are the same proteins that are needed for normal function in healthy cells. And so when we do this, we get various side effects that are very severe. So we need better, more effective treatments for cancer. And this comes from better understanding of what's going on. We used to think that a message passed in the cell through a set of proteins had a particular outcome, but we now appreciate that messages sent through the same set of proteins can have different outcomes. It's not just which proteins are involved, but also the timing and the location of the message that's important. Now, this makes sense. Timing's important. If you tell your mate Dave you love him over dinner, you'll get a different response than if you told him that after a night out drinking. Location is also important. If you turn around to somebody on a dance floor and say, do you want to dance? You'll get a different response than if you ask them when you're at the toilets. The message can be the same, but the timing and location are important. I'm interested in how cells transmit signals, and my research is on scaffold proteins. Scaffold proteins act as meeting points that bring together the different proteins involved in passing a message, and thus help determine the timing and the location of the message. I'm interested in a particular scaffold protein called KSR. It doesn't cause cancer, but it acts as a meeting point for proteins that can cause cancer, and thus helps determine the timing and location of the signals and messages that are passed. So, for my thesis, I aim to set out everything that interacts with the scaffold protein KSR, and importantly, where and when those interactions take place. If we can better understand this role that KSR has in cancer, we'll be able to develop more effective treatments for patients, help the local economy with the many drug companies here in Ireland, and in the future with this research, it might be the person to the left, or the person to the right, or you that gets the cancer, but there'll be more that we can do to help. Thank you.